Word problems come in all shapes and sizes, and we're going to begin with what I call number problems, where you pretty much just read the problem and hopefully your equation flows straight from it. Twice, that is a word that tells us we're going to be multiplying by 2, but it's not just twice a number, it's twice a sum of a number and 3. So instead of 2x plus 3, which is a very common mistake, that's only twice the number and then adding 3, we're going twice the sum. And so it's twice that whole addition problem, and you need to use parentheses in this, okay? Twice the sum of a number and 3 is, that's going to be our equal sign, the same as 1 subtracted from the number. Be careful, do not write 1 minus x, it's x minus 1 because the 1 is being taken away from the number that already exists. Okay, if you get past that hurdle, now you just have a linear problem, a linear equation to solve. Let's begin by distributing the 2 on the left-hand side, and that will give us 2x plus 6 is equal to x minus 1. There are no like terms to combine on either the left or the right, and so now it's time to get all the x's to the same side. So I'm going to subtract x on each side of the equation, and that will give us x plus 6 on the left is equal to negative 1 on the right. And then subtracting 6 from each side will give us x is now equal to negative 7, and that would be our solution set. Now all word problems are checkable if you choose to take that answer, in this case negative 7, and substitute it back into that top row. Twice the sum of a number and 3. Well, if our two numbers are negative 7 and 3 and we want to find their sum, we get negative 4. It says twice that negative 4, which gives us negative 8, and that should be equal to 1 subtracted from the number, which we're saying is negative 7, and that does work. So this is a true statement. Consecutive integer problems show up throughout your algebra classes, and it's important that you have an understanding of how they work. Consecutive means right after each other, and if you have consecutive integers, they might be numbers like 7, 8, and 9. Because we have the word integers, you cannot have fractions and you cannot have decimals. You'll have nice clean numbers here. And algebraically, they are represented by x plus 1, and if you need another, x plus 2 and x plus 3. And I'll put a dot 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 after that. Consecutive odd integers would be numbers like 7, 9, and 11. Notice how odd numbers are 2 apart, and so algebraically they would be represented by x plus 2, x plus 4, etc. And consecutive even integers would be numbers like 8, 10, and 12, which are also 2 apart and can be represented by x plus 2, x plus 4, etc. Notice that the algebraic representation of both consecutive evens and consecutive odds both have x plus 2 and x plus 4. A common mistake is to look at the word odd and want to go x plus 1 and x plus 3. But that will not work, because to go from x to x plus 1, you're not adding 2 to go between those two numbers, and that really gets you into a trouble. So this is pretty much your code list that you're going to be using anytime you have consecutive integer problems. Okay, reading this problem, 4 times the smallest of 2 consecutive odd integers. Automatically, when I see 2 consecutive odd integers, I know we're going to be dealing with x and x plus 2. X plus 2 because we're dealing with odds. Now 4 times the smaller, that's 4 times the x, is the same as, there's my equal, 73 less than 5 times the larger. That's 5 times the larger, x plus 2, then minus 73. Be careful that you get the order of subtraction correct, and you put the minus 73 at the end, because that's being subtracted away from 5 times that larger, not 73 minus that value. Okay, now we have a linear equation to solve, and we want to begin by distributing the 5 on the right-hand side. our equation now becomes 4x equals 5x plus 10 minus 73. And then we have some like terms on the right-hand side which we can combine together. Doing that, we have 4x equals 5x minus 63. And we want to get all of the x's together on the same side of the equation. So I'm going to subtract 5x off of each side to get all the x's on the left-hand side, and that leaves us with negative x is now equal to negative 63. Well, we are never solving for negative x. We want to divide or multiply each side by negative 1, and that will give us x is equal to 63. Now don't just stop there. It does not just say, hey, find my x and I'm done. It says find the integers. And up at the top we said we're dealing with x and x plus 2. So the x plus 2 that goes with this is going to be 65. And so our solution set are the two values 63 and 65. 4 times the smallest of 3 consecutive even integers. I see the word even there, so I know I'm dealing with x, x plus 2, and x plus 4. Now 5 times the smallest of these, that's 5 times x, is, there's my equal sign, 10 more than, I can put a 10 plus 10 at the end, but because addition is commutative, I might as well just go 10 plus right now. Twice the largest, that's 2 times the x plus 4. Notice we did not put x plus 2 into the equation, but that wasn't necessary. We only needed the first and the third number to set this up. The second number is still there when we go to write our solution set. So we're going to solve this linear equation by first distributing the 2. We're going to have 5x equals 10 plus 2x plus 8. And then, as always, we want to combine like terms. So on the right-hand side, we have 2 constant terms which can be combined. We now have 5x is equal to 2x plus 18. I will then subtract 2x on each side of this equation. That will leave us with 3x is equal to 18, and dividing each side by 3 we get x is equal to 6. Notice that it is an even number, and that's what we were looking for because it did say 3 consecutive even values. Now again, the word problem says find the integers, and we need to add 2 and add 4 to 6 to get our full solution set, which will be the numbers 6, 8, and 10.